try and shoot this video for you so you can have the answer key to the problems I gave you in class, and you can see me solve through them and have the right answers. So let's get rolling on this. So let's look at question 1, okay? And every one of these are like a different, it's kind of like the same scenario, but different things and different things that you're looking for. Alright? So in this, first question says, Mr. Hall stands on top of the school that is 15.87 meters, okay? 15.87 meters from the ground to his hand that is holding a tennis ball. In this case, you need to be able to determine whether information you're being given means something or doesn't. So in this case, we're looking at 15.87 meters from my hand to the ground holding a tennis ball. If Mr. Hall releases the ball from his hand, what is the velocity of that ball when it hits the ground? This is a really good problem because you're going to have to be able to pull information from it, because literally the only thing that I'm giving you is a change in displacement, which is 15.87 meters. So from this, we've got to find some certain information. So I'm going to label it over here on my left side of the paper. I'm going to label all my stuff. So initial position, final position, initial velocity, final velocity, acceleration, and time. And the reason I'm labeling all these is I know these are things that we've been using in class. These are what we're looking at. We're looking at one-dimension motion, so I can pull information from this. So in this case, we got to start setting our scenario. So what is happening? Think about what's taking place here. So the first thing we have going on is we are literally taking a ball and dropping it. So everything is happening in the down direction. So everything's happening down. In that case, this is what I'm going to do, is set down as positive. Hold on a second. Alright, I'll shoot a video.
Dylan, don't talk about Taylor like that.
So, if you have questions, actually what I'm doing right now is I'm actually, like this sheet that I'm giving you guys today in class, I'm recording me working the answer key so I can upload the video so that you guys have it. Would you want the worksheet to try and work through it now, or do you have specific questions?
I would like to
Yeah, I
have the
just
worksheet.
needed extra practice, because I think I'm understanding it.
I have zero idea what I'm doing. Well, I mean, I have the basis, but
Alright, so just with this, just know that like I'm going to roll through this because I got like lunch to get this done because it's going to take time for the video to buffer. Braxton?
Mr. Hall.
Alright, so in this, you guys haven't missed nothing. I'm literally just rolling through. I've just took the information that's been given to me. I labeled it here. I've set over here on this left side all this information.
your shopping list.
Don't worry about having to drop by, down, or anything. If you run in front of the camera, it doesn't matter. This isn't professional grade. I mean, this is just for you all. So I'm putting together a little shopping list over here. So a little piece of information that I can use. So in this case, alright, everything's going down. So I'm going to set, like I said before, I'm going to set this, the down direction is positive. So everything that's going down is going to be positive. In that case, I'm making my final position 15.87 meters and making my initial position 0 meters, choosing my axis and choosing my points. So down is positive. This makes sense because I'm holding the ball above the school and it's going down and it's going into a positive region. So my initial velocity, this is the thing, is right here's the key, and hopefully you pick this up. You can find that initial velocity because I release the ball. I don't sling it, I release it. So in that case, my velocity is 0 meters per second. Now, final velocity, I do not know. How do I know that I do not know? It's because, what is the velocity?
Of the ball when it hits the ground.
of the ball when it hits the ground. So that is my final velocity that I'm trying to find. My acceleration, in this case, acceleration is going to be gravity, which is 9.81 meters per second squared, which is a beautiful thing for me. Now, from here, do I have time? No. So, we are encountering quite a little pickle of a problem here. So, something to help you out. Do not run away and be scared of writing these formulas down. We got a shopping list now. Let's write our formulas down. Final position equals initial position plus initial velocity times time plus 1/2 times acceleration times time squared. Along with this, we have final velocity is equal to initial velocity plus acceleration times time. Then we have our final velocity squared equals our initial velocity squared plus 2 times acceleration and the change in displacement, which is x final minus x initial. In this, we are trying to find something to find this final velocity from the information that we have over here. So start looking at what you have in these and start checking it off. I'm automatically going to discard these two. And these are why I'm going to discard these two. I don't have time. And they both are using time. Now, the key to this is this top one doesn't include a final velocity. So I could solve that to find time, but I don't want to do that. So let's look. I got final velocity squared. I don't know it. I'm going to box it. I have initial velocity. It's 0. I have the number 2. It's just a number. I have accelerations, 9.81 meters per second squared. I have a final position and an initial position. So I can solve this. So the setup for this problem is going to look like this. Okay, and I'm going to jump here. Final velocity is equal to the square root of 2 times acceleration, position final, minus initial position. And in this, just plugging numbers in, 2 times 9.81 meters per second squared times the final position, which was 15.87 meters. And I'm going to end that quantity. And think why I can end that quantity is right here. What is the initial position? It's equal to 0. So I can just take it out. Now in this, we just jump to a handy-dandy calculator.
Available heroes, report to the auditorium.
Have fun.
It seems very interesting.
Alright, so in this, hopefully you can see this. All I've done is punch that in the calculator. And I end up getting 17.64537, and this is velocity meters per second.
That's what I got, doing it by myself.
That's awesome.
I'm happy.
It means you're learning.
I'm learning.
I got it too. I can.
Probably shouldn't highlight that, but 17.64. I'll just write it over top of it. I don't know how this is showing up on the videos. Hopefully it's looking good. So, we answered that problem. Bada boom, bada bing. Now, new scenario. Moving from question 1. If you have questions on question 1, I literally just solved the problem. Take your finger, scrub the video back, and watch it again. Let's go to number 2. Alright, number 2. Mr. Hall stands on top of the school that is 15.87 meters tall from the ground when he slings a tennis ball with a velocity of 4.85 meters per second. That should say downward. I apologize for that. This is downward. So,
I'm going to make down positive again.
I have that change. I have the velocity here. So what is the velocity of the ball when it slams the ground? So velocity of the ball when it slams the ground. What is the acceleration of that ball when it is 10 meters from the ground? And how long does it take for the ball to hit the ground? So, do what we did before. Let's go over here. Think about our scenario. I'm going to make me a shopping list. So, I'm looking at initial position, final position, initial velocity, final velocity, acceleration, and time. In this case, think about your scenario. I'm throwing this ball, and this ball should be thrown down. I apologize for that. Hopefully I'll remember to tell you in class. So the ball's been thrown down. In that, let's just do what we did up there. Everything's going down. Let's make the downward direction positive. So now in this, we can start filling in information. So, our initial position is still 0 meters. Our final position is still 15.87 meters. But our initial velocity has now changed. We start with an initial velocity here of 4.58 meters per second. Final velocity, we do not know. We're trying to find that, as well as trying to find the time, so how long does it take, and we're trying to find the acceleration. Do not overthink this. You're at acceleration right here. You know the answer to this. What is accelerating the ball?
1.81
Gravity, which is 9.81 meters per second squared.
I had that thing raised to it.
Can I ask a question?
You can.
How come initial position isn't 10 meters since that's where we're trying to end up instead of the ground?
Because I want you to think through this problem.
Okay.
What is the acceleration? When something okay, let's say you jump off a building onto a trampoline. What's accelerating you? Gravity. Does gravity change whether you're 10 meters in the air or 10 meters down? Doesn't change. So what is acceleration? That was a kind of a trick question, but a give you question. Acceleration is gravity. 9.81 meters per second squared. And it does not change. It stays the same. Now, time. How long does it take? We don't know. So we have to solve for it. See what we did before?
It should have, like, it was.
Write your formulas.
And then I like went to go pull it out, and the door was closed at the same time, and the whole key let me get sideways. Sorry, can I come in?
Yeah. Velocity final equals velocity initial plus acceleration times time. Then we have final velocity squared is equal to initial velocity squared plus 2 times acceleration. And that quantity is the final position minus the initial position. Now in this we're going to have to do a little bit more. That's why it's the same scenario but some different things added within it. Let's start looking at this. Alright? So I'm going to solve for the velocity first because that's what I'm being asked for. Velocity of that ball. In that case, I do not have final velocity, but this is set up for me to find it. I have initial velocity, I have acceleration, and I have the positions. I'm set to solve for this final velocity. Now I'm going to immediately jump to this because we've already solved this not only in class but also earlier in this video up there on problem 1. And we find that initial velocity squared plus 2 times acceleration times final position minus initial position is what we're looking at. Initial position is 0, so we can toss it out. You cannot toss out initial velocity. I know you automatically want to jump to it because you did it before, but you can't here. You have to think through this. You now have an initial velocity. That has to stay. So we'll start plugging numbers in here. So initial velocity is 4.58 meters per second, and that whole quantity is squared. It's going to be plus 2 times acceleration, which is 9.81 meters per second squared, and that is times, it just ends up being my final position, which is 15.87 meters. So you're pretty much looking like you were at the problem before, but we're starting with an initial velocity here.
Thank you.
When you solve this, I'll show you what I punched in the calculator here. If I can get the glare off of it. I put it all under the radical. Now I know some of y'all, just like in class, you're probably not going to want to put this in the radical like I have it. You're probably going to want to solve the inside here. And once you get that, then you're going to want to set that radical up. And that's totally fine. It's whatever you want to do, whatever you're feeling. Either way is going to work. You're probably, if you do it that way, you're probably not going to end up with this 18.2304 meters per second. But I'm okay with that. We're not caught up with you having to be exactly the same. You're probably going to have, like, these last two numbers. That 04 is probably going to change up, and it's not going to be the same. Here, Kate. I'll give you a class.
I stood in line the entire first lunch, and then I had to eat lunch, and now I've only got like a little bit of time left.
You're fine. Alright, so in this, we figured out what that acceleration is. Remember, that was a give you question. It was something that was just there to just give you some points. It wasn't that complex or complicated. This velocity of that ball was a little bit more complex though, because we started with that initial velocity. So we solved it. If you wonder what I'm doing, I'm recording it so that I can send this out to you all later, because I'm giving you this in class. But since y'all came on in here, I went on and gave it to you, so you can work with me as we go. But I want you guys to not only have the answer key, but I want you to also be able
The
to...
volunteers who has not signed the card, please go to Mr. Halsey's room at this time.
All right. All right, so we're not done with this problem yet. We're trying to find out how long does it take. Ladies and gentlemen, let's figure this out. I got faith in you. In this case, let's look at our other formulas. We are looking for time. So you're literally narrowed down to these two. It's got to be one of these two because they are the only two that are involving time. So in this, whenever we're looking at this, do we have a final velocity?
Yes.
Do we have an initial velocity?
Yep.
Do we have acceleration?
Yep.
And we're trying to find time. So we can use that one. But, hear me out. Do we have initial or final position?
Yeah.
Do we have initial position?
Yeah.
Do we have initial velocity?
Yeah.
We do not have time. We're trying to find time. We know 1/2. We know acceleration. We're trying to find time. You can also use that, but that's probably going to terrify you all right now. If you're wanting to use this, you're going to have to use the quadratic formula. If me saying that is terrifying you, then forget this. Go with this. Okay, so in this, we're just going to start rolling through this. Final velocity equals initial velocity plus acceleration times time. I have to get time by itself, so we're looking at final velocity minus initial velocity is equal to acceleration times time, and time will be equal to final velocity minus initial velocity all over acceleration. And let's just plug this stuff in. So, we solved for that final velocity down here. 18.2304 meters per second minus our initial velocity, which you started with 1. Don't automatically jump for a 0 here. I know you can't see that. Let me slide that over some. There we go. Let's get in. I'm new to this. Okay. You're starting with an initial velocity. Don't automatically jump to want to say that that initial velocity is a 0 because we had before. Think through the process. So 4.58 meters per second. My numbers are the units are getting very small there. Acceleration's 9.81 meters per second squared. I want to stress this out to you right now. On this number right here, we solved for this number. If you have 2 places on your decimal that's slightly off here, or this number is just slightly off, you should end up with 18.2. You have to have that. You shouldn't have that big of a change in it. But if that 3, 0, and 4 is slightly off, it's okay. But think this through also. If that's going to be slightly off, you're using that information, so this answer here will also be slightly off. But use your math on your quiz so that I can follow along with you and see what you're doing so that you get full credit. And this is all I did in the calculator. Again, without that glare, I just took the 18.2304 minus the 4.58, and then once I got that, I divided by the 9.81 to give me 1.3915 seconds. And the whole reason I got that 5 is because of that 4. That 7 behind that 4 made it round up. Okay? If you have questions on this, you have this video to refer back to. If you have questions on this, please ask me. That is what I'm here for. You have opportunities. You can come see me at the beginning of the day when you get here at 7:05, or you can come in during second lunch, like some of you are sitting here right now. I'm so proud of you. Look at you all.
I have a question.
Yes.
Why is it that your final, and you might have explained this, but
You're fine. No, you're fine.
Why is your final position 15.87 instead of your initial position? Because you're on top of the building, aren't you?
I am, but I switched my axis, where my origin of my axis is, to where everything will work out to where I made down as positive, and everything's going in the down motion right now. So it makes everything positive for me if I make my initial position to be 0, because what you're looking at there is a great question, is your change in displacement is the 15.87 meters. That's the change in it. It's up to you however you want to make that.
Okay.
So in my case, I want to make my final position to 15.87 because I want to deal with positive numbers. So if I start where I'm 0, I've only went from where my hand is down to the ground. So it doesn't matter. Like here's my hand, here's the ground. It's 15.87 meters between them. That quantity can't be changed. But these two can be changed. You set it. So since we set this as 0, this has to be 15.87. But if you end up setting this, I can't use that color, as 15.87, you're going to be looking at making this, it's going to be what you want it to be. You could keep everything positive, but you're going to have to add 15.87 to it down here and get that number, or you can look and say that's 0, but then that's going to change everything, because as you're going down, in this case, in the blue, it's negative.
So
you're making it down as negative.
So if we, for some reason, do make it like that, as long as we like show you our math, show you what we did.
Yes.
You're okay.
Because on this, on your back of yours, there is this third problem. And I left this whole sheet on here blank for a reason. This thing is more complicated. The only thing we've done is every time I've just added another piece of information or changed something. In this case, I've changed something. Okay, and I'm not going to have time to like put this in the video because we got 3 minutes before the bell's going to ring on us. But I'll stop this video, send this all to you, and I'm going to try and get this third one done and sent to you, but it's not guaranteed because I got to go to Barbersville with my wife later. In this is the difference. You still have that velocity, that's 4.5 meters per second, but here's your change. I threw it upward in the air.
Well, this is one of those trick questions where it's the same answer before in the last problem.
What's the velocity of the ball when it slams the ground? In this case, yeah, that will be the same. But what changes, and this is why I added this on here, how long does it take? You're looking at the whole system from when it leaves my hand to hit that ground. How long does it take for the ball to hit the ground? In that case, there's going to be a change. The velocity is going to be the same. Why? Because if something goes up in the air and it comes back down, it's literally what's accelerated it and decelerated it. Gravity the whole time. So if something comes up in the air and it comes back down at that same point where it's going down, that I threw it up, it has the same velocity, but the direction's changed. And that's why in this case, whenever I would work this problem, I'll go on and tell you guys, in case I don't get to solve this on a video and get it out there to you guys, this velocity, at 4.58 meters per second, I'm going to make it negative so that my down direction is still positive. Because I want as simple as I can get. You have a choice. It's either your initial velocity has to be negative and your gravity and positions will stay positive, or you're going to have to flip it to where you're going to end up having the initial velocity is positive, but then your gravity and those positions have to change negatives. And my goal is to solve it both ways. I just don't know if I'm going to get it done in enough time for it to read or be sent to you guys, okay? But I am going to be sending you 1 and 2. Like I will be sending this out on Remind. So if you're not on Remind, you need to make sure and get on. Even if you need to do it like today in 8th period, do it. You need to do it.
So are problems like this going to be like the problems on the test?
Yes, these are created from my mind.
So are these kind of in the category of the easier ones or the harder-ish ones?
Hardest ones. Like this one right here, this first one, this number 1,
Yeah.
it's not extremely hard. That's kind of like I want to see where you're at, and I want to test the waters with you. But when you get to number 2, I'm pulling on you.
Well, I did number 2 by myself and not the same answer as you did.
That's fantastic. Number three is I'm going to see if you really know your stuff.
I signed up for Remind,